Alright, so today we'll be talking about the properties of exponents. So let's get started. So we're going to review what an exponent is, and then we're going to list and explain the various properties of exponents. So let's recall exponents. So when you see something such as x to the n power, that means that the base, x in this case, is raised to the nth power, and will be multiplied by itself that number of times. So for example, 2 to the second power is 2 times 2, which is 4. An important note is that you want to be mindful of what is actually in the base, and that mainly comes down to whether you see parentheses. So for example, you see the negative 2 to the fourth power. That one doesn't have the negative 2 included in the base. It's the 2's being raised to the fourth power rather than the negative being raised. So that would equal negative 16. But if you had a parentheses around the negative 2, then that's going to have the negative 2 be part of the base, and as such, the result there would be positive 16. And another example is when you have parentheses around a 2x, that means that the 2x is going to be, it's being raised to the third power, so it's going to be multiplied by itself 3 times, leading to 8x cubed, rather than if you just had 2x cubed, that then the x is the only one being cubed there. And when I say cube, that refers to like when you see something to the third power, and when you see something to the second power, that's called squared, which you can see at the bottom. So now, with that, we can get on to the properties. So the first property is if something doesn't have a power written, then that just means it's being raised to the first power. So when you see x with nothing on it, that's this. You can think of it the same thing as x to the first power, or any number that applies to that. The next rule, if you see a base raised to the 0 power, then that's going to equal 1, except if you have 0 as the base, which in that case would be undefined. So in examples here, you see x to the 0th power equals 1, and then we have this big number here to the 0th power, and that's also 1. Very basic. Next rule is when you're multiplying powers that share the same base, you're going to add the exponents together. So in this example, we have x to the 8th times x to the 7th, and that's going to equal, in the end, x to the 15th. And then on a similar note, when you divide powers that share the same base, you're going to subtract the denominator exponent from the numerator one. So x to the 15th divided by x to the 10th is going to end out as x to the 5th. So a few more properties here. When a base is being raised to a power multiple times, you just multiply the powers. So you see y raised to the 6th power, and then you see that y to the 6th power raised to the 5th power, and that's going to be equivalent to y being raised to the 30th power. So this next rule is saying that the sign of an exponent will flip when it and the base are moved between the numerator and the denominator. So there's two examples here. First is an example of the term with the negative exponent being in the numerator. So y to the negative 4th would be equivalent to 1 over y to the 4th. So that's that term being moved to the denominator to flip its sign to be positive. And then the second case is 1 over y to the negative 5 is equivalent to y to the 5th power. And that's an example of the term with the negative exponent being in the denominator and then being in the numerator by switching the sign. And then this last property is that when a whole fraction is raised to a negative power, you're going to flip the numerator and the denominator. So for example, you see x divided by y to the negative third, and that's, you could has the parentheses around it, so that's the whole fraction being raised to that power. And that's equivalent to y over x to the third power, so the denominator and the numerator switched, and the power became positive. So now we have a few practice examples, and for these I want you to simplify them using the properties we've learned and when I say simplify it, I mean try to get it down to a single term, that has positive exponents. So I'm going to start showing the solutions here in a second. So if you want to work on these by yourself before you compare with mine, now's the time to pause and do that. And I'm turning now. So this first one, x to the 6th power times x to the 3rd power times to the 9th power. So first, we have the x to the 3rd power raised to the 9th power. We're just going to simplify to x to the 27th. And that leaves us with x to the 6th times x to the 27th. And you're going to add those to get the 6 and 27 together, and that's going to leave you with x to the 33rd power. The next one, y to the 5th divided by y to the 7th. We know that when we have the same bases being divided, we subtract the denominator from the numerator, so that's going to leave y to the -2. But since I said we wanted positive exponents, you're going to want to flip that to the denominator to make it a positive. So the final answer here is 1 over y squared. And lastly is 5z to the 4th times z to the -4th. So we know that when we have the same bases being multiplied together, we add them. So we have 5 times z to the 4 plus -4, which is going to simplify to be 0. And that means z to the 0th power is just 1, and that's going to leave 5 times 1, which is just 5. So we don't even have the variable in that one. So yeah, hopefully that all made sense. Feel free to leave any questions or comments to clarify anything if you need that. And I'll see you guys later.